welcome you in this video. In current short video, we are going to discuss, I am going to explain about the how to make the chemical equation more meaningful. This is the part of topic chemical reactions and equations. Before starting that how to write the chemical equation as well as how to make the chemical equation more meaningful, please try to understand that earlier in one of the video I have stated this, but here also let me recap. What is chemical reaction, what is the word equation, and what is the chemical equation, that I'll tell you. For example, if we bring combustion of coal, okay, so we know that coal on combustion forms carbon dioxide. Major chemical change I am discussing. So this statement is the statement of the chemical reaction. Okay, that reactant we have coal, it react with oxygen, result in the formation of carbon dioxide. That is the chemical. This is the chemical reaction. Now that chemical reaction which occurs somewhere, maybe practically it occurs, that chemical reaction, suppose here I wrote coal get combusted. For the combustion oxygen is required. So when react with the oxygen, result in the formation of the carbon dioxide. So what it is here, this is the word equation. I'll write word equation. Okay, so reactant and the product, they are separated by the arrow pointing from reactant to the product. So that is the word equation. First statement, that statement is nothing but the chemical reaction, and this is the word equation. And we are going to talk about the chemical equation. What it is? Say for example, coal, that is nothing but the carbon, oxygen, it exists in nature in the form of O2. Okay, and when they combine together, result in the formation of the carbon dioxide. Okay, just simple idea I gave. This is the chemical equation. Okay, what is chemical reaction, what is word equation, and what is the chemical equation? That simple basic I try to complete here. Okay, chemical equation. Now the main thing of the current video is how to make this chemical equation more meaningful. Very oftenly in the notes, in the over the board in classroom, as well as in the different books, all we are seeing the different chemical equations. These are the chemical equations. Okay, one example here I kept, few more examples we'll see. How to make the chemical equation more meaningful, how to write the chemical equation properly. Okay, that things we are going to discuss. Some points I want to share with you. So let's start. Here, so as to write the chemical equation as well as so as to make it meaningful, the first thing is that what? Reactants. Okay, if feasible, please make a note simultaneously. Reactants and products in the form of their formula. Okay, plural I am making, LAE, in the form of formula, sometimes symbol are written at the LHS and RHS respectively. What it means? We should write the reactants at the left hand side of that equation, and the products we should write at the right side of the chemical equation. I know most of the students, for them it's a very basic, but for the 10th class state board, for the 10th class CBSE, as well as for those which are learning newly about the chemical reactions or chemistry, for them it is useful. Otherwise those which know, they may see into two speed. Okay, now I'll give the example here. Say for example, twice of S plus O2, thrice of O2, result in the formation of twice of SO3. So here we have the reactants. Which are the reactants? Sulfur and oxygen. These reactants in the form of their symbol we have kept at the left hand side of the equation. Product is kept at the right side of the equation. Correct? So this is the first point, reactant left side, product right side. Okay, simple things, but we should have the touch of these. I am stating the, here I'll write reactants and here I'll write the products. Okay, suppose you are making the notes, you should stop the video and then you can copy, and later on you may proceed to see. Okay, let me proceed now. Second thing what we should do, the second point to make the chemical equation more meaningful is arrow. Okay, arrow, which type of arrow? Single headed arrow. Single headed arrow pointing from a reactant to product indicates irreversible change. Okay, for example, which are the irreversible changes? Yes, combustion reaction is the irreversible one. For example, methane on combustion result in the formation of carbon dioxide and water vapor. Okay, so here we have the 4 hydrogen atoms. I'll write here 2, and now the equation is balanced. So this arrow, what it indicates? Here I wrote a single headed arrow. Single headed arrow, in bracket you should write this arrow. Okay, pointing from reactant and it is towards the product. It indicates the formation of the it indicates the irreversible reaction. Means what? Only the reactant get converted into the product. Product can't reunite to form the reactant. Irreversible. Okay, and here 2 oppositely directed half headed arrows indicates a reversible change or reversible reaction. Okay, easy one. Okay, so reactants are converting into the product and products are again back converting into the reactant. Okay, say for example N2 plus thrice of H2 result in the formation of twice of NH3. Okay, see, reactants are converting into the product and product ammonia is again back converting into the reactant. Okay, so the reaction is carried out in a certain closed container so as to increase the yield of the ammonia. That is the different one. But what we are noticing, just I gave the example, reactants are converting into the product, products are again back converting into the reactant. Okay, so this is the example. You can write that reversible reactions. Okay, and here the main thing is that 2 oppositely directed half-headed arrows. So here in bracket these are the 2 half-headed arrows oppositely directed. So this thing, then what we should do so as to make the chemical equation more meaningful? Okay, you may take screenshot and afterwards also you may write. Then so as to make the chemical equation more meaningful, third thing we have to do is, wherever possible we should mention the catalyst temperature, pressure, okay, like that parameters. Somewhere the heat energy is given, somewhere electrical energy, light energy is given, etc. These parameters, etc. should be mentioned, over the arrow. Okay, let's see. Here we are talking about the change, okay, in which reactants are converting into the product. Say for example vegetable oil. All we are familiar with the different vegetable oils, okay, soya bean, groundnut, sarki and so on, different vegetable oils, sesame and so on. So vegetable oil, when treated with the hydrogen, this is called as the hydrogenation of the vegetable oil in presence of nickel as a catalyst at a 60 degrees Celsius temperature. It results in the formation of vegetable ghee. What we call vegetable ghee, dalda, margarine, these are going to form. So What is the third point? Say catalyst, temperature, sometime heat energy is given so as to bring the chemical change. For example, CaCO3, calcium carbonate, limestone. If we provide the heat, it results in the formation of the calcium oxide and carbon dioxide. So whatever the physical parameters we are giving, temperature, pressure, so these things are to be mentioned here. Okay, now let me tell some more things. Okay, next one, that some more symbols, other symbols I'll explain here. Fourth, okay, triangle. What triangle indicates? Triangle means heat energy is provided. Okay, just we saw the example of CaCO3. Let's have example of MgCO3. On thermal decomposition, it forms MgO and CO2. What it means? This triangle means what? Heat energy is provided. Okay, then suppose if we bring mercurous oxide, HgO, okay, in presence of light, h nu, in this form also it can be written, h for the Planck's constant, nu for the frequency of the light. So h nu is nothing but the light, electromagnetic radiation. Okay, so it results in the formation of twice of Hg plus O2. Okay, so the triangle means heat energy is provided, h nu means what? Light energy is provided. Okay, so these parameters also we should write over the arrow. Okay, this is the point number 4 I told. Then fifth one, we can mention the amount of heat. Okay, for the 10th class it's not required, but you may mention the amount of heat provided. For example, N2 plus twice of O2, it gives twice of NO2. This is the one change, and here 66.4 kilojoule energy is get released. So that much specific information also we can give. Okay, here say for example twice of KClO3, if we provide 78 kilojoule energy, so it results in the formation of twice of KCl plus thrice of O2. Okay, I hope no need to give the statement, or should I give for the statement for the point number 5? I'll give. Okay, better, please write that wherever possible, amount of energy released or absorbed should be mentioned. Okay, so in higher classes you will see these values here. When these reactants unite together, this much energy, 66.4 kilojoule, okay, that much energy is released. Here this much energy is when provided to the 2 mole of potassium chlorate, then potassium chloride and oxygen is get released. Now let's have a point number 6 about some more arrows. Okay, point number 6 is upward directed arrow. This is the upward directed arrow used when gaseous product is formed. Very common. Okay, say for example twice of C plus O2 result in the formation of twice of CO. Okay, carbon monoxide, poisonous gas. When carbon is get combusted in limited amount of air, result in the formation of carbon monoxide. So this carbon monoxide, so as it is a gaseous product, if gaseous product is formed, we should mention either by upward directed arrow, or we should write here small g. Okay, one of that we should do here. Okay, so upward directed arrow means what? Gaseous product. For the reactant we should not use. If product is in gaseous state, we can use the upward directed arrow. Okay, sometime the precipitate formation takes place. Okay, insoluble solid product, what we call it as precipitate. insoluble solid product precipitate should be shown, okay, should be indicated by downward directed arrow, okay. This is the downward directed arrow. I'll write here the equation. Barium chloride BaCl2 plus H2SO4, it will form BaSO4 and HCl, twice of HCl plus BaSO4. So BaSO4, here I am showing the downward directed arrow, okay. So this is the precipitate insoluble solid product is formed, so that is to be indicated by the downward directed arrow, okay. Then next one, means whatever things we know, suppose here we have the equation 6 point, I gave 7 point, for example copper sulfate, okay. Copper sulfate plus zinc result in the formation of zinc sulfate plus copper, okay. We know that reactivity series of the metals, that zinc is more reactive, correct. So zinc, here 7 point I want to tell. Let me complete first of all. Zinc is more reactive, zinc is displacing copper, correct. Zinc is taking place of the copper, so that's why zinc sulfate is formed. That is another part. Here we are seeing the equation how to make meaningful. So we should write the physical state. Zinc, it is in solid state, it is to be denoted by small s. Copper solid state product, so it should be mentioned as a small s. This is in aqueous state and this is in the aqueous state. So what is the 7th point? Okay, here physical state and abbreviation. See, small s, small l, okay, G as well as AQ. What it indicates? Small s, it stands for the physical state, solid, the reactant, either reactant, product, whatever it may be, that is the solids. L, of course you know all, L for the liquid, G for the gas and AQ for the aqueous, correct. So this is all about the physical states, okay. Wherever possible we should mention the physical state of the reactants as well as the products also, okay. And one specific thing, let me tell you with example, that is, say for example copper plus nitric acid result in the formation of copper nitrate, CuNO3 twice plus twice of NO2 plus twice of H2. This is the one equation. And another equation is thrice of copper plus 8HNO3 result in the formation of thrice of CuNO3 twice plus twice of NO plus 4H2. See, it's what we are seeing, copper plus nitric acid forming copper nitrate, nitrogen dioxide, water, and in this case nitrogen monoxide and water. What is the difference? Number of moles of reactants are different, but beside this, here when we use the concentrated nitric acid, we are getting the reddish brown colored the nitrogen dioxide as a product, and when we are using the dilute nitric acid, then we are getting the product nitric oxide, NO, which is comparatively less harmful, less poisonous, okay. Nitrogen monoxide, sorry, nitric oxide or nitrogen monoxide, okay. It is reddish brown colored poisonous gas. Of course, here also we can mention physical states, aqueous, gas, liquid, aqueous, so on, okay. So here the 8th point is specific condition, concentrated, dilute, that words also we should put there, okay. Sometime in some chemical equation we should write 1 mole, 2 mole, okay, or the pressure of the gas, suppose reactants are there in gaseous state, so 1 atmospheric pressure of gas A, 2 atmospheric pressure of the gas B, like that also we should mention, okay. I hope it might be a worthy. Okay, thank you for watching. Okay, bye.